We're going to take a look at these sample size questions that occur with our confidence interval modules. So the key thing here is to realize that you're not solving for a confidence interval. What you're doing is you're trying to calculate the sample size needed, right, so that you can construct your confidence interval, but also maintain some margin of error that you're wanting or that you desire. And so here are the formulas we need to notice. These are not the confidence interval formulas. These are the formulas we use to estimate the sample size. Now, they come from the confidence interval formulas, but notice it says n, right? That's the sample size. And so what we're trying to do is a calculation to determine the minimum sample size needed. And so we have two different sides here. We have this side over here that I'm highlighting now. This formula is when we're dealing with a confidence interval, right, and sample size with a quantitative variable. When we're looking for when we're dealing with means, trying to estimate the means, right? So of a quantitative variable. So here's the current problem, and this is the formula. Now these formulas look similar too. They look complicated, but it's again just about identifying the values that we have in the situation and then substituting them in and using the calculators. You can see the Desmos calculator on the bottom here. And so this over here on this side is minimum sample size needed for proportions when we're looking at a categorical variable and we're dealing with proportions. And so we have two formulas depending upon our situation. Most of the time we're going to be using the one with the 0.25 because rarely do we have, most of the time we don't have an estimate for the population proportion. And so most of the time it's unknown and we use the 0.25. Okay, there are rare cases where we have that other one of the values and we use the top one, but it does exist. So let's take a look at these two examples first. We're going to focus in on the means first. So in this case, we're trying to limit our margin of error to 25 points. So whatever estimate we're going to have for this SAT score, we want to limit it to 25 points, but we still want 95% confidence. And so we have certain values that go with that. And so if you look carefully, we have the standard deviation that we're going to use here. And then that's given here. We have the critical Z that's associated with the 95% confidence interval, and that is again right here. And then your margin of error. And then all we do is take those values and then you substitute them into this equation, just like this. It looks like this if you're doing it by hand, and it looks like this if you're using a calculator. And we get 553.19. What that number is the minimum sample size needed to meet these conditions. Now, this is a greater than or equal to symbol. So in this case, then we will then say we at minimum need 554 students, right? We round up because this is the minimum sample size and I need students and I can't have 0.19 students. So if I only put 553, that's not bigger than 553.19. So that's why we round up to the nearest person. Now take a look at this here's another situation. This is a little bit more complex. You're given a little bit more challenge here, but we're still dealing with a proportion, and you can see we have a confidence interval already calculated. And so in this case, we're curious how many people were actually sampled given this scenario. And so we can calculate the Z star in this situation because we know it's a 90% confidence interval, and that's 1.645. Now, we don't have any information about what the population proportion is before this, the parameter. So we end up using this formula down here on the bottom. We have the Z, now we're looking for E. Now the margin of error, and this problem was given to us, that's what we wanted beforehand. In this case, we already have the confidence interval, so we can calculate the margin of error from that confidence interval. So my estimate, right, is between 68.9% and 75.1%. And so the margin of error is the value from the point estimate to the endpoint, right, to your lower and upper bound. So I just need to calculate that value from the point estimate. Now, there's a simple formula that we've talked about. Is what you do is you just find the distance between those two. So you subtract those two values and then divide by 2. So that's giving you this length here. And so it's 3.1% or 0.013 margin of error. With that, we then go ahead and substitute that value into the equation. You have 0.013 goes for E, plug it in, you get 703. It looks like that. It looks like this using your calculator. And then we need how many students on this one also. So in this case, this would be 704 students are needed. Again, rounding up, not because it's closer, well, it's rounding up because we need a number bigger than this. I need a whole number bigger than this, and the next nearest whole number is 704, right? That's greater than or equal to. And again, the challenge was coming up with this margin of error, and that really what we're doing is finding the distance. The margin of error goes from your point estimate to your upper or lower bound. And so this was kind of a little mathematical trick to do that. Find the distance between this point and this point by subtracting and then dividing by 2.